Hi everyone, this is Dr. Umar. In this video I will show you how to explore data distribution in SPSS. The first step in data analysis is to explore your data. There are several methods and ways to explore the distribution of the data in SPSS. The first one is to draw a histogram and look at the distribution of the data and insert a normal curve and then determine and check whether the data are normally distributed or not. The second method is by plotting a box plot, and from that it is possible to envisage whether the data are normally distributed or not. A third method is to plot a normal quartile QQ plot. So from these three graphs, histogram, box plot and QQ plot, it is possible to tell whether the data are normally distributed or not. Skewness and kurtosis is another terms that used to describe the data that are not normally distributed. So skewness and kurtosis can be checked and determined through two different ways, either plotting the three graphs, histogram, box plot or QQ plot, or through a statistical analysis that SPSS can generate value for skewness and kurtosis, and from this value it is possible to determine whether your data is normally distributed or not, or the data are skewed or not, or it has kurtosis in it. Another way that is also exploring the distribution of the data, if the data is to do a statistical test, SPSS can perform normal distribution test and can determine whether the data are normally distributed or not. The most common used test for normality are the Kolmogorov, Smirnov test and Shapiro Wilk test. And finally, looking at the homogeneity of variance, also one way of exploring your data, and the test is used for that is the Leaven's test. The first way to explore the data in SPSS is to draw a histogram, and from that histogram it is possible to tell whether the data are normally distributed or not. Here I have a data here on the left hand side. As we can see, three different scores, and I want to look at the distribution of the data on those scores. Before I proceed and do any statistical analysis, it is essential and crucial to look at the data and determine whether it is normally distributed or not, because the distribution is critical to this critical and prerequisite for whichever test you want to go. So if it is normally distributed, then you go for parametric test. If it is not, then non-parametric. In this video, I will show you 4 different ways how to plot your histogram. The first one is if you click on the graphs here, and they click on legacy dialog and scroll down up to this icon where it says histogram. Hit the button for histogram. I will reset this, and then here another window appears and it says in the left hand side score 1, 2 and 3, and then it's give you the variable. So I'm going to move the variable number score number 1 to the variable here, and there is here a small box. It says display normal curve. If you tick on this and then hit the button for OK, SPSS will generate a histogram, and as you can see here, the data are normally distributed. However, histogram can show you here there is a value for a data that is extremely high. This data here, this value here is called an outlier because it is really an extreme value from the rest of the scores. So that's one of the benefits of using histogram in SPSS, and before you do a statistical analysis, to look at the data and sort out these issues. So it's here from the graph, even we can see that there is a 10, there is a value of 10 for this for this participant. And if we go here, and we can see it's at number 691, the value is 10. Now another way to draw a graph is to go through chart builder. If you click on chart builder, you will get another window. Just click on OK, and then here it will show you different option. Click on gallery and go scroll down to histogram. Click on the histogram and bring that histogram here. So we're going to check the distribution through histogram for score number 1, and if we move the score number 1 to here, and SPSS will make a histogram graph, and just we leave the rest as it is, and then we hit the click button. Okay, and again it shows you here the histogram. Again, this histogram have frequency distribution but without curve, and to insert a curve we double click on the graph and then go to elements and then click on show distribution curve, and it will show you now that so it will insert a normal curve on the histogram. So this is the second way of showing you how to do a histogram. Then there are another ways also, a third way. If we go to analyze and then click on descriptive statistics and click on frequency, and then another window will come up, and we need to look at all these three groups together. We click on the score 1, move score 1 here, and then 2 and 3 scores to here. And if we click on statistics, I think we probably will leave it as it is because we are interested more in chart. In chart here there is an icon for histogram. Click on it and then click on also tick on show normal curve on the histogram. On the format we'll leave it the same, and the style we'll keep it the same, and then we hit the OK button. And if we scroll down, of course the SPSS will calculate, give you a descriptive tables, and then at the bottom it will generate a histogram for each score, score number 1, score number 2, score number 3. Again, as we can see here that in score number 1 you have an outlier, and data are normally distribution except for the outlier. In score number 2 the data are not normally distributed, and we call it skewed here. As you can see, the curve, the data cluster to the left, and also for score 3 the same. A fourth way of doing a histogram is through descriptive, and then we go through, click on explore. We could transfer scores, all the 3 scores, into the dependent variable. Okay, and then if we click on statistics, we keep descriptive, we'll get some descriptive plots. It's very crucial here to untick the stem. We are not really interested in stem and live at this stage. We click on histogram and click on continue. In options we will keep the same, these window the same. Click on continue and then click on OK. Again, SPSS will generate a descriptive table and show you a histogram for score 1, and then histogram for score 2, and a histogram for score 3. And again, as I showed you, if you want to insert a histogram, you just click on the graph and then click on the element and then insert the graph. So this way, now I showed you I have shown you 4 different ways of how to do draw histogram in SPSS, and to look at your data, scrutinize your data, screen your data to see if there is any abnormal values in it, or if the data are distributed or not distributed, as it is the first step in toward doing a statistical analysis. A second way of exploring the distribution of the data is in SPSS is to plot a box plot. And from the box plot, it is possible to determine whether the data are normally distributed or not through inspecting the graph and scrutinizing it. And I want to draw a box plot for them. I have 3 groups of data, data 1, 2, and 3. So the way to draw a graph is to click on the graph icons and then legacy dialog, and then scroll down to the box plot, click on that, and then click on the symbol, click on summaries, because we have 3 groups, 3 variables, 3 columns, then summaries of separate variables. So we click on define, and then I'm going to transfer these 3 data into the box which says box represent. If we click on options, I don't think we are going to make any changes here. Click on continue and then hit the button for OK. SPSS will generate an output showing a box plot for all the 3 columns or variables or groups. And again, as you can see here, it can tell you really what is this distribution, whether normal is or not. In data 2, the whiskers are not equal, and data 3, the whiskers are not equal in length, and the median here is shifted toward the bottom Q1. And if we notice also, there is a star here which says a star and a number in it, and this is to indicate you have an outlier, an extreme value, and this is the number of the value within your data. And if we click on it, you will go to the value to the case number 774, and you will find out that it has a high value. So this is one of the way to do and to draw box plot. Another way is also to click on graphs and then build the chart yourself. It's called chart builder. You will get a new windows before using this measure. Then you just go and hit the bottom, the icon OK, or the bottom button. And again here, a description come which graph do you want to draw. So we scroll down up to the box plot, and we have different choices here as a group or as an individual, and I'm going to use as an individual. So I'll move this to here, and then I'm going to select, let's say, data 3 and place it in that box, and then hit the bottom. And here I'm not going to change a lot, so I'm going just to click the OK button, and again SPSS will generate a box plot for data 3. A third way of drawing box plot is to click on analyze, click on descriptive statistics, and then click on explore. In the explore here, we're going to look at the 3 columns of data or variables or groups, and then if we hit on statistics, it will keep this box and window as it is. Plot, what I'm going to get rid of stem left by itself, and just ignore it, and then click on we leave the histogram, click on continue, and then options, we'll leave the option itself, and then hit the button for OK. The SPSS will generate an output that's showing 2 tables with median, mood, and mean, and all the things. However, and skewness, this is not currently an issue here. So it also will generate a box plot for each data one by one. Here we have data 1, here we have data 2, and here we have data 3. So, and by looking at this box plot, we can really determine whether the data are normally distributed or not. So I hope you had really now have an idea how to draw Boxplot in SPSS and how to envisage the distribution of the data. A third method of exploring the distribution of the data is to draw a normal quartile QQ plot in SPSS, and from the plot it is possible to determine whether the data are normally distributed or not. Here I have a file with 3 groups, data in 3 groups, label them as data 1, 2 and 3, and I want to look at the normal distribution of this data using the QQ plot. The way to do it, I usually do it using 2 ways or 2 methods. First, you click on Analyze and then scroll to Descriptive Statistics. We have here 2 options, either to use the Explore or to use the QQ plot. I'll click first. I'll show you how to do it through QQ plot, and then how to do it through Explore. So if we click at QQ plots, a window will pop up. Going to look at, we can look at all the 3, or we can look at one by one. So if I select the first one, the data 1, and I'm not going to change anything here, and just click on OK, SPSS will generate an output giving you the number of the cases and so on, and then it will generate a QQ plot. And if we look at the QQ plot here, we can see the diagonal line, which is the expected value or data, and the circles, the black circles or dots, are all nearly aligned on the diagonal line. So this indicates that these data are normally distributed. And so we can go back again and do the rest for the other variables or data if we wish to do so. The other way I use it, and I usually use it, is to go through Analyze and then click on Descriptive, scroll down to Explore, and then here a window will pop up, and I'm going to look at here again the dependent list, move the data 1. I can move 2 and 3, but I will look at data 1. And if I click in Statistics, I'll keep the descriptive the value as it is. On the plot, I'll click on that. I'm not going to look at STEM, not histogram here, and but I'm going to click on an icon here. Click on and tick on the normality plot with tests, and it will give you plots here, Boxplot, which is not an interest to us. I will explain it later on in another video. If we click on Continue, and then if we want to click on Options, we'll keep the same box as it is, and then if we hit the button for OK, again SPSS will generate another output, but this will give you more details. It will describe give you details for the means, median, variance, and so on, and it will also generate a QQ plot. And again, the QQ plot showing here that these data are false or fall along the diagonal line, so these data are normally distributed. So, and now by this I had shown you 2 ways to draw the QQ plot, either to go through Analyze and then click on Descriptive QQ plot, or through Explore. Another way of investigating and checking and scrutinizing your data is to check whether the data are skewed or not. Skewness means that the data deviates from the normal distribution. So when the data are skewed, it means the data are not normally distributed, and the data can be either positively skewed or negatively skewed. So there are 2 different and common ways or method to look at skewness in SPSS, either through plotting histogram, QQ plot, or Boxplot. And from looking at these diagrams and plot, scrutinizing them, it is possible to envisage whether the data are skewed. Another way is SPSS generate a value for skewness and calculate that value, and from that value it is possible to tell the data are normally distributed or not. Right, here I have 3 different groups: group A, group B, and group C, and I want to examine and look at the distribution of the data in all these 3 groups, and to check whether it is normally distributed or not, and whether there is a skewness or not in any of these groups. And as I mentioned before, there are several different ways to do that, either through plotting the histogram, or QQ plot, or the Boxplot, or through calculation, in which SPSS calculate the skewness value and determine the value, and from that value to determine whether there is a skewness or not in your data. So we'll do the first one, which is plotting a graph of histogram. If we click in graphs and legacy dialog, scroll down to the histogram, click on histogram, reset this, and again we have here the ID and the 3 groups A, B, C. I'm going to move the group A to variable, and then I'm going to tick this box which saying display normal curve, and then I'm going to hit the button for OK. Again, if we look here, we can see that SPSS has generated a histogram and a curve on it, and as I can see, that's fairly normally distributed data in group A. Now we go back again and do the same thing for group B. And if we come here to look at this histogram in group B, as we can see, the data are clustered into the left side, and the curve here is not normally pill-shaped, pill-curved, but however it's more skewed toward the positive sign. So this is a positively skewed data. Now if we go again and do the histogram for the final group, which group C, and click OK. Again, here for group C, we can see that all the data are clustered into the right hand side, and the curve is not pill-shaped, however it's tailed toward the negative signs, so this one is a negatively skewed data. So we have here a fairly normal distributed data with a pill-shaped normal curve, here a skewed data that are positively skewed, and here a negatively skewed data. So this is the first way of looking at your data and exploring them through plotting histogram and looking at the distribution, whether they are normally distributed or positively or negatively skewed. Another way is we can really go through a chart builder and go for Boxplot, select on, reset this Boxplot and select this one here, and then we repeat the same thing again for group A. And if we move group A to here and then click OK, the SPSS will generate a Boxplot. Again, as we can see from this Boxplot, the 2 whiskers are nearly fairly equal, and so that's indicate these data are normally distributed in group A. Now if you go back again and do the same for group B again, and as we can see here, group B is really a little bit deviated from normal distribution, as one of the whiskers, this whiskers, is longer than the smaller one. So the data are not normally distributed. And again, if we go back again and do it for the final group, we will also get another box. Sorry, that's the same group. We need to do it again for group C. Group C, we'll move group C here and then click OK. As we can see here now, the two whiskers are not equal, so that indicates that these data are not normally distributed and they are skewed. So data in group C are skewed and data in group B are skewed. The third way is to look at the distribution through plotting QQ graph, and I've had a video on that describing how to do that. If we go through, click on Analyze and then click on Descriptive, scroll down to PPQ, and then going to on the left hand side to move all the three groups into the variable group A and group B and group C, and then hit the button for OK. SPSS will generate a few tables and then it will draw the normal QQ plot or the quartile plot. Again, for group A, we can see it's fairly normally distributed. For group B, as again, it is curvy shaped compared to the diagonal, and in group C, it's again curvily shaped also, and it is not normally distributed. The final way is through calculating the skewness, and to calculate the skewness of the data we have three different options, either through frequencies, descriptive, or explore. So we click on Analyze, Descriptive Data, and then we will choose the first one, which is frequencies. So what I'm going to do, I'm going to move all these three groups into the variable box. I'm not going to untick this because it will give me a frequency tables for all the data. So I'm going to untick it, and then for statistics I'm going to choose here the mean and the median and the mode, and also in the distribution tick the square or the icon for skewness. And we could also tick on description, standard deviation, and standard error of the mean if we would like. Then click on continue. On the chart, we're going also to get histogram with showing normal curve in it, and hit the button for continue. In the format, we are going to leave everything as it is, and in the style, we are not going to change anything. And if we click the button for OK, again, SPSS in the frequency options will generate a table for group A and B and C, do some statistics, and it will calculate the mean, the median, and the mode for all the three groups. And if you follow the description and the PowerPoint I have made, you will really, that will make sense when we look at the mean and the mode and the median. Again, the SPSS also generate a skewness value for all the three groups. For group A, the skewness is 0.049, which is really fairly close to the 0. It's not further away from the 0, it's 0.05. So this fairly can indicate that these data are nearly normally distributed. However, group B and C, as you can see, it's 1.3, positive 1.3. So is positively skewed, and group C is minus 3.117, which means negatively skewed. Again, SPSS generated the skewness value for each of these groups. And again, if we want to do the scoreness, z-score for all the three groups, we can really work it out, as we have said, is dividing the skewness on the standard error of the skewness and then getting the z-score and then comparing the values. Again, the frequency options also give you the normal distribution of the curves, normal distribution and curves for each group. Group A, So you can see here it's normally distributed fairly. Group B is skewed, and group C again it's skewed. Now this is one of the options. Again, if we click on analyze and click on descriptive, and then now choose the option for descriptive, reset this, I'm going to move all the three groups into the variable box, and then in the options I am going to select standard deviation. We don't need maximum and minimum, standard error, and you need to click on the skewness options here icon for distribution, and then hit the button for continue. For style we keep it as it is, and then we click on OK. Again, the SPSS will generate a descriptive table here for group A, B, C, and saying that there are 100 items in each group or score. Let's give you the mean for each one of them and the standard deviation, and it's worked out the skewness and the standard error of the skewness. For group A it's 0.04, and for group B it's 1.3, and for group C it's -3.1. The final way also to look and check for calculate and explore your data is to choose the options from analyze, descriptive, statistics, explore 1. So if we reset this, and then we're going to move these three groups, move them into the dependent list, click on statistics. Don't think we are going to change anything here, just we keep it as it is. And the plot, we're going to untick this, we don't need this stem and left. We're going to take on the histogram, and then normality plot with test, click continue. In the options section we're not going to change anything. Here in the display we're going to have both statistics and plot. Hit the button for OK. SPSS will generate a few tables and few charts. Here we can see the cases summary for A, B, C as 100 scores in each group. Again, in option of explore in analyze, the table is generated for group A and B and C. The mean is calculated, the median, and the skewness with its standard error for each group. And again, it is similar to other options in SPSS. And if we just hit here quickly, if you are familiar with the test of normality, again, I have already described these two tests, Shapiro, Wilk, and Kolmogorov, Smirnov, in a separate video. The group A, it shows that it's normally distributed, and B and C it's not. The SPS also generated histogram for all the three groups, a histogram, a QQ plot, and also a box plot. So in this histogram, again, it's fairly distributed, and if we want, we can really click on the double click on the graph, and then go to elements, insert a curve, and then we have now a normal distributed curve above this histogram. And again, we can see from the QQ plot that it's nearly normally distributed, and from the box plot the data, the whiskers are nearly similar. And the same thing for B and group C. So in this way I had shown you several different ways of how to explore your data and to determine visually whether they are normally distributed or not, visually and through calculation, statistically, visually through drawing a chart for histogram, a QQ plot, and a box plot, and through calculation SPSS will calculate the skewness value for each group you have. Kurtosis is another term that describes deviation from normal distribution of the data. Kurtosis indicate pointness of the data or flatness of the distribution of the data. So here on the left column I have data, and I want to explore this data to see whether it is normally distributed or not, and whether there is kurtosis in it or not. I'm going to show you 3 ways to do it in SPSS. If we go and click on Analyze and then scroll to Descriptive Statistic, then hit the button for, or the icon for frequencies, and then we're going to transfer the data I have here into the variables. And then when I click on statistics, I'm going to select few things. One of them is the mean, the median, the mood in the central tendency, and then the distribution. I need to check the, put a check mark, tick the kurtosis, get also standard deviation, a standard error of the mean, and hit the button for continue. If I click on the charts, I'm going to need to look at the data through looking at histogram and then examining the curve. So tick this and tick histogram, and then click on continue. Click on format. In the format, I'm not going to change anything in this window, so we keep it as it is. So click continue. And the style, we're not going to do any changes. Here there is a box or an icon, small box, say displays a frequency table. I'm going to uncheck that. There is no need to look at the data in a frequency table. So if I hit the button for OK, SPSS will generate a table. In that table shows that we have 44 entries or scores. Nothing is missing. Is the mean for it, the median, and the mood. It worked out the kurtosis, and it's found to be 1.2, and then standard error of that kurtosis. And 1.2 is further away from 0, so that indicates that there is kurtosis in these data and the distribution of this data, so that that indicate that this data is not normally distributed. If we look at the histogram of this data, we can see that the curve is really pointy. The data are pointy, so there is a positive kurtosis here. So this is one of the way to examine the data. Another way is to click on Analyze, Descriptive, and then go for this again. Click on the descriptive icon. We're going to transfer the data into the variable, and then if we click on options, it will give you some other options to select from: mean, standard deviation, maximum, minimum, and then distribution. Click on the icon for kurtosis and then hit the button for continue. If we click also in style, we are not going to do any changes, and then we just click on the button for OK. SPSS will generate a table showing that you have 44 scores, the mean for it, and then it worked out the kurtosis to find out to be 1.2, and the standard error of kurtosis is 0.7. A third way also, again, descriptive, explore. In the explore window, transfer the data into the dependent list. Click on the statistics. Not going to do any changes, just hit the button for continue. In the plot one, we're going to untick stem and tick the histogram, and also we're going to look at the normality plot with tests to see whether this data are normally distributed or not. If we click on options, we're not going to do any changes. Plot, we have already done that. And then here in the display, statistics and plot, we're going to look for both. If we click the button for OK, the SPSS will generate few tables. Again, the descriptive table will give us a mean, a median, range, and minimum, and also kurtosis. Again, it works out the kurtosis mathematically and calculations, and worked out also the normality. Again, as we can see here, using these two tests, these data are not normally distributed by looking at the p-value here, and I have a separate video clip describing normality test in SPSS. Again, the SPSS will generate a diagram, histogram diagram or chart, and as we can see here, we have the data, and we see a peak here, and there is no curve, but if we want to insert a curve, we just double click on this picture and then scroll to elements, scroll to show distribution curve, and then close this, and then we have here a curve. So this histogram shows that these data are positively, and there is positive kurtosis at its pointy or peaky. Okay, this is the three ways how to get the value for the distribution of your data, whether there is kurtosis in it or not, through analyze, then descriptive statistics. Either you choose frequency, descriptive, or explore. Another statistical method based in calculation that determine the distribution of the data, whether it's normal or not, is Kolmogorov, Smirnov, and Shapiro Wilk's test that is performed by SPSS. Here I have a data from 100 students attending. 50 of them are in medical school and another 50 are in biomedical schools. They had scored scores and results for 2 modules or courses, biology and immunology. And before moving forward and performing any statistical test, we need first of all, and the first step, to look at this data and check whether they are normally distributed or not. So I will show you 3 different ways how to do the KS test in SPSS. The first one is if we click on analyze and then scroll down to descriptive statistics and then to explore, click on it, a window will pop up and you will have here the variables. So I'm interested in the biology and immunology, so I'll move this and shift them into the dependent list, because those are the 2 variables I need to check their distribution, or their distribution whether it's normal or not. I could put the colleges into factor list, but we'll keep it as it is. So if we click on statistics and we keep this descriptive ticked on, click on continue. In the plot sections, in the descriptive box, just uncheck the stem and then check the normality plot and with tests. That's what we really want the software to do. Click on continue. In the options icon, just keep it as it is, and here we need to make sure that we get display of both. If we click on OK, the SPSS will generate an output, as we can see here, with multiple tables, and I'm not going to go through this, the first one and the second one, because I will describe them in more details in a subsequent video clips. The most important one is the third table, which is a test of normality. Again, the KS test and Shapiro-Wilk test for biology and immunology. And as we can see here, that the p-value for biology is less than 0.05, and so thus these data in biology are not normally distributed, as confirmed by both these 2 tests. However, the immunology scores is normally distributed because the value of p-value is greater than 0.05 for both tests. So this test concludes that the biology modules is not normally distributed. However, the immunology module is normally distributed. A second method of testing the normality is if we click on analyze, scroll down to non-parametric test, and then scroll down to legacy dialog, and then scroll down to one sample KS test. Again, a window will appear. You have 3 variables here, we are interested in biology and immunology, we'll shift them into the test variable list. And we have here test distribution. We need to make sure that the normal distribution test is ticked on. If we click on exact, we are not going to change anything here. We just click on continue. In options, we'll just put, can we click on descriptive and then click continue. If you hit the button for OK, again, SPSS has generated a few tables and a few diagrams. We are interested in this table or this box here where it say one sample KS test. Again, from this test we can see that the biology and the immunology modules, the p-value for it is 0.02 for biology, so this is not normally distributed, and for immunology it is normally distributed. Again, this is the second way of checking normality. The third way is to go to analyze, click again into non-parametric test, and then go for click on one sample. A window will appear and it will ask you questions. What is your objective? You just click on automatically compare observed data to hypothesized. If we click on the field, I'm going just to reset this. I'm going to remove the college. So I'm going to test the field for biology and immunology. And then if I click on settings and then click on customize data, there is an icon here for test observed distribution against hypothesized KS test. Tick this one, and if we click on options, we make sure that it's normal, and then click OK, and then hit the button for run. The SPSS will generate an output. Again, the output for biology course and immunology course. Again, it's telling you here that reject the null hypothesis because it's less than 0.02. So the biology data are not normally distributed. However, for immunology, it's showing that telling you that retain the null hypothesis as the p-value is greater than 0.05. So parametric Leaven's test is one of the tests to determine the homogeneity of a variance in SPSS when exploring your data. I'm going to show you 4 different ways to do it. To start with, I have here a data for 40 individuals. They are divided into 4 groups. In each group, group A to D, in each group there are 10 participants or individual or cases, and a score has been recorded for each individual, and we need to look at the heterogeneity or homogeneity of variance between all these 4 groups. Before we start doing the test, first step to do is to plot your data on a scattered plot, scattered or dot plot. And the way to do that is to go click on graph, click on legacy, scroll down to scattered or scatter dot, then click on overlay scatter, click on define. Here I'm going to move, again it does tell you where do you want to put the group in X and Y axis. Groups will put the groups in the scores in the Y axis and the groups in the X axis, and then title will not do change anything, and here will not do anything, and then we click on OK, and then a scatter plots, scattered or scatter or dot plot will appear. And as we can see here, it's fairly to indicate that the variance are homogeneous between those 4 groups. However, we will do the test. The first way to do the Leaven's test is to click on Analyze, scroll down to Descriptive Statistics, and then scroll down to Explore. And then here we want to move the groups into the factor list and the scores into the dependent list. And if you click on Statistics, we're not going to do any changes. Click on the plots, I'm going to untick this descriptive for stem and leaf. We're not interested in normality, so we're going to there is here a square is here area says that spread versus level with Leaven test. So we're going to click on untransformed, and so we need to do the Leaven's test. Click on continue. However, in options we're not going to do any changes. So if I click on OK, then the SPSS will generate an output. Of course, it will give a case processing summary that you have 10 samples in each group, you have 4 groups, and then it will give you the mean, the range, and so on. And then here in a small table, it's giving calculated the homogeneity of variance using Leaven's test. And as you can see here, the value, the significant, and generated the p-value. And we can see here from the p-value, the p-value is about 0.4. So that still it is non-significant. Thus we reject the null. They are not significant. Thus we accept the null hypothesis, and that indicates that the data have homogeneity of variance. This is the first method to do Leaven's test. Another method is to click on Analyze, scroll down to Compare Means, and then I'm going to click on Independent Samples t-test, because Leaven's test is a prerequisite for this test and it's part of this test. So we're going to move the groups into the grouping variable, and then I'm going to set here. I can select which group to go to because it's two for 2 groups, and we have 4 groups. Either I can go select 2 groups together, 1 with 2, 1 with 3, and 1 with 4, or 2 with 3, or 2 with 4, or 3 with 4. Here I will stick to 1 with 2 and click continue. And then I'm going to move the score to the test variable. And I'll click on option, and we're going to keep it as it is. And then I click on OK. When you click on OK, the t-test will generate a table calculating for you the value for the t-test. But what we're interested in here is it does automatically generate Leaven's test of equality of variance, and between group number A and group number B. And it's the significant, it calculates the p-value. The p-value was found to be greater than 0.05. So this indicates that there is equality of variance or homogeneity. So this is the second way of doing a Leaven's test. A third way is if we click on Analyze and then again Compare Means, we're going to use here the test of one-way ANOVA. In one-way ANOVA, I'm going to move the scroll to the dependent list and then the groups into the factor. Again, one-way ANOVA is going to compare the 4 groups together. So I'm not going here to select, it doesn't give me an option to select which group to group together. So it's look at the overall variance in all 4 groups. If I click in contrast, I'm not going to do any changes. Post hoc is not an interest currently for us. Options, In this option, it's significant to go for statistic and click on the homogeneity of variance test, and then click on continue. And if you hit the button for OK, again, the one way ANOVA will calculate the p-value for the test, Leaven's test, and this in this small table which says test of homogeneity of variance, it's worked out to be 0.4, which is greater than 0.05, so it is not significant here, the value. So that's where we can here accept the null hypothesis, and we can say here that there is an equal or homogeneity of variance between samples. This is the third way to do Leaven's test. A fourth way is to again go through, click on analyze, and then look for click on general linear model, and then click on univariate. In univariate, again, the group, the dependent variable is the score. We move this into the dependent variable, and the groups we move that into the box of fixed factors. On the right hand side, I'm going to double click on this universal univariate model. Just keep it as it is. Contrast, we keep it as it is. Plot, we are not interested currently in doing the plot. Post hoc is not an interest currently. How save options. Here in options, you have in the display, there are different icons. So if we tick this homogeneity test, and then click on continue, and then hit the button for OK, the test, the SPSS will do Leaven's test of equality of the error of variance, and again it worked out the p-value and found to be 0.4. Thus, the variance between groups is homogeneous. The p-value is greater than 0.05, so we accept the null hypothesis. So by this way, I had shown you 4 different ways to do Leaven's test. The first way is through descriptive, the second way through ANOVA, third way through t-test, and fourth way through univariate.